Hello everyone, my name is Hemu and today's we are here for the Palo Alto Firewall Day 2 class, and in today's class we will entirely discussing the packet flow in your Palo Alto Firewall. So generally let me tell you how people used to ask this particular question in the interview. They will ask can you explain the packet flow of Palo Alto Firewall? Maybe they will ask, can you explain the life of a packet inside the Palo Alto firewall? Okay, so they will ask this question in these two type of ways. Okay, and if time permits, I will basically try to cover the initial access. Once these two topics will be completed, and guys, after that, you have a time of 5 days. Okay, on these 5 days, just revisit these two recording like your day one recording and day two recording two times at least, so you will grab all the things. And even though if you will able to answer these two questions in the interview properly, you can able to crack. Okay, because here we have discussed so many things. Okay, cool. So let me go here. So guys, if you will see in this diagram, I have one PC. This PC is a part of my inside zone, and this PC is behind Ethernet 1x2 interface. And that PC have IP address 10.1.1.70. This is my internal PC. I have my Palo Alto firewall, and Palo Alto firewall Ethernet 1x1 interface, which is a part of outside zone. And in outside, basically, let's say we have a server somewhere over the internet. Okay, and let's suppose that server have some IP address. So let me just take one hypothetical IP address. Let's suppose this server have IP address which is 151.7.1, and that server is running the web services on TCP port 443. Okay, this is the setup right now we will be having. So guys, as I also discussed yesterday, let's suppose this PC wants to start the communication with this particular server. So when it will start the communication with this particular server, the very first packet which is initiated by this PC is your TCP SYN. Right now, TCP SYN received by the firewall. Firewall do the processing of TCP SYN, and after that, he will basically forward this particular request over this server. That's true, right? Now, if we want to see how this particular firewall is doing the processing for TCP SYN, let's try to understand that part. So as I have mentioned in your yesterday session as well, Palo Alto firewall have a packet processing stages, and every packet needs to go through with these stages, right? So guys, and these are the things which you need to remember. So I'm just putting here TCP SYN packet processing. How this packet gets processed by the firewall? Now when firewall receive this packet, what it will do? It will send this packet through the ingress state. Ingress stage. Then this packet go towards the flow lookup. And after that, silo path, which is a session setup state. Then it will go towards the fast path. This fast path is also known as layer 2 to layer 4 processing. Then the fifth one, this packet go towards the forwarding stage. This is how the TCP SYN packet processing done by this particular firewall, which is Palo Alto firewall. Now this SYN request reach till this server. Now this server will give the reply, and when he will give the reply, he will send the second packet, which is TCP SYN plus ACK. Now this TCP SYN plus X received by the firewall, and what firewall will do? Firewall will start the processing of TCP SYN plus X. Let's try to understand how the packet is processed by the, how this TCP SYN plus X packet, which is a second packet in your TCP three-way handshake communication, how my firewall going to process. Packet processing. And guys, these processing you need to remember, okay? Then only you can able to troubleshoot the issues. So the very first packet, this first packet when received by the firewall on Ethernet 1x1 interface, what it will do? It will put this packet into the ingress stage. Then your flow lookup. Guys, is this time my firewall, when it will do the flow lookup into the flow table or into the session table, this time it will found the session detail, right? And if firewall, what firewall used to do when it will found the session detail? It will bypass the silo path, right? Why it is bypassing the silo path? Because my firewall, this firewall is a stateful device, right? It is a stateful device. So your packet directly go into the first path. And after that, your packet go into the forwarding stage. And finally, this packet reached here. Now this PC will send next packet, which is a third one. In TCP three-way handshake, third packet is just an acknowledgement, right? ACK. Now, when this acknowledgement packet received by the firewall, what firewall will do? Firewall will start processing the third packet, TCP packet processing. So what it will do? It will do the ingress stage processing. Then it will do the flow lookup. Then again fast path, because session is already there. When it will do the flow lookup, it will found the session, so it will directly move toward the fast path and your forwarding stage. Now this server received this packet, and after that, because you know guys, this server is hosting the services on TCP 443. So what is the next packet which is initiated by the PC1? What is the first packet now? Like what is the packet number 4th? One person get like HTTP get, HTTP get. There is a one person called HTTPS get. And I got the correct answer from Kalpesh. That's true, Kalpesh. In once till here, what happened till here, till this particular time, till here, your TCP three-way handshake has been completed. TCP three-way handshake is completed. Now your SSL handshake will start, because you know this this server is hosting the service on HTTPS 443 used by the HTTPS, right? So now they will start the SSL handshake from here. In SSL handshake, what is the first packet? First packet is a client hello. So this is the packet number 4th, which is client hello. Now when this firewall receive this client hello, how this firewall going to do the processing? Let me put the client hello processing here. Ingress stage. Then your fellow lookup. Then your fast path. And after that, now guys, it will not go into the forwarding state. It will go on app ID. Then it will go for the content identification. And after that, it will go towards the forwarding stage. That's how the client hello has been processed by the firewall. Now guys, tell me one thing. Why firewall is not sending TCP SYN plus ACK and TCP ACK packet towards the app engine and content engine? What was the reason? Are you guys know what is the reason here? And I got the correct answer from Rahul. Yes, Rahul. Because guys, TCP SYN plus ACK and ACK, these packets, they don't have any type of layer 7 content. Because if they don't have any type of layer 7 in content, or they don't have any data at layer 7, then there is no sense to forward these particular packet SYN plus ACK and ACK towards the app ID and content ID. Okay, that was the reason, and you have to remember that reason. Because in interview, maybe they will ask, you have configured the application based policies, but your firewall is not blocking that application right away. TCP three-way handshake is happening. Now you know the reason why like TCP three-way handshake is happening. Because SYN plus ACK and ACK, they don't have any layer 7 content, and by looking into these three packets, my PaloAlto firewall is not able to identify the actual application. Your actual application, he will identify when client hello you will receive, either you will receive the next packet from the other end. Okay, cool. So guys, generally when PaloAlto receive these packet, it will start processing like that. Okay, now let me move further. Let me just explain you the other part of it. So what used to happen? We have a client, which is an initiator, and we have a server. And when this client will start communication with this server, it will create a client to server flow. And if my firewall allow the client to server, means it will allow this traffic, then whatever reply will come, this reply will automatically allow by the firewall. Why it is allowing this particular reply packet? Are you guys able to answer this thing? Because stateful inspection, and your security policy is a part of silo path, right? And now it is not sending the packet into silo path. It is directly sending the packet towards the fast path. It is bypassing the silo path, right? So that is the reason it will allow that return packet right away. Okay. Now, so generally what used to happen, if you will see, when firewall receive a packet, it will put this packet into the ingress stage. And after ingress stage, we have a flow lookup. Then we have a silo path. Then we have a fast path. Then we have a application identification. Then we have a content inspection. And after that, we have a egress processing or forwarding stage. Egress stage or forwarding stage, both are same. And in your ingress stage, what used to happen generally, it will receive a packet on the interface. It will detect and drop the packet if there is any header errors. Detect and block the pre-session or packet based. So let's suppose if someone trying to launch any type of DDoS attack, and if that IP address is a part of DDoS block table, it will basically block that particular packet as well. So what I will do, these are the things it will basically check into the ingress stage generally. Then we have a silo path. In silo path, what? It will basically do the routing lookup. It will check the net policies. It will check your security policies. It will check your DOS policies, all these type of things. In fast path, it will do the net translation and decryption. In app ID, it will try to do the application identification. In content, it will try to scan the layer 7 information if there is any type of virus or malware available in the layer 7 payload. And in forwarding, it will basically try to forward the packet. It will apply the quality of service and all these things. Now let me just go here. Let me just explain you the same thing in detail. And guys, I will just take a reference of two diagrams. Generally, I will just refer this diagram. This is the guy latest packet flow according to the latest operating system of your Palo Alto firewall. And just tell me guys, are you able to see this information clearly? Increase the size little bit more. 78. This is the only size I can able to set here. Cool. Okay. Now let's try to understand this particular things now. So guys, these stages you can remember because we have discussed multiple times. So what used to happen generally when we receive a packet? So that generally that packet is always received by the Palo Alto firewall on the interfaces, Ethernet 1x1, Ethernet 1x2, Ethernet 1x3, all these interfaces. Let me be clear, guys. If you will receive any packet on management interface, this packet will not process by the Palo Alto firewall according to the packet flow. Okay, because you know this particular traffic coming for your firewall into your management interface. Management communication is always separate. This packet flow is applied for your data interfaces. Just remember. So when we receive a packet, so let's suppose there is a one PC and your inside network PC1 having this IP address 10.1.1.70. He has initiated that packet and that packet received by the Palo Alto firewall on Ethernet 1x2 interface, and this interface is a part of inside zone. And this is your firewall. So what used to happen when this particular packet received by the firewall, what it will do? It will extract the layer 2 information, which means your source MAC, destination MAC. It will extract your layer 3 information, which is your source IP, destination IP. It will extract your layer 4 information, which is your source port and destination port. And guys, because you know, my firewall know I have received this packet on Ethernet 1x2 interface. Means it's know the ingress interface, because you know this is the interface where I am receiving the packet. So that interface become like a ingress interface, right? So my firewall know I have received the packet on ingress interface, and he will do the zone lookup. What is the zone associated with this ingress interface? And he will find out this zone is inside. He will get the zone detail here. Now what he has a source MAC, he is a destination MAC, he is a source IP, destination IP, source port, destination port, and also he has a detail of source zone. Now, sometime what used to happen if we have received the packet in fragmented, let's say we have received the fragmented packet. So what used to happen for the fragmented packet, they used to do the IP reassembly, means they will make the full packet and after that only it will start the packet processing. Okay. So that's how these are the things which it will perform on this particular box. If you will see this box, these are the things it will basically check in this particular box. Like packet ingress process, extract layer 2, layer 3, layer 4 information. Then do the, let's just look for the ingress interface, got the source zone, do the IP fragment reassembly if required. And after that it will move further towards the ingress process errors. Means now it will check the header errors, basically if there is any error in the header, because you know sometimes the headers they used to have some type of errors. Basically what are these errors? packets may be discarded in your ingress state due to the protocol violation. Protocol violation means, let's suppose there is a one hacker. He had just modified the header details in IP header and your TCP header and UDP header, right? We have some predefined fields, right? These fields, they have some limitation and other thing. Let's suppose if somebody has modified these particular fields, means if somebody did the protocol violation, such type of packets is dropped by the firewall right away. Firewall attack prevention features may discard the packet without configurable option because those packets would eventually be discarded by end of the host anyways. Means the meaning of this line is that, let's suppose in the firewall we have received first packet as a SYN plus ACK. Can you expect the first packet SYN plus ACK, guys? What is the first packet in TCP 3-way handshake? SYN. If you have received the directly SYN plus ACK packet, firewall will basically, what firewall used to do, it will basically prevent that particular packet. And after that, guys, what they will start the, what I have told you the extraction. What they used to do, the packet parsing. They will start doing the packet parsing at your layer 2, at layer 3 and layer 4. Information is extracted and ingress interface and zone lookup it will perform. Now let's try to understand what it will use to do in your layer 2 parsing. In your layer 2 parsing, it will basically extract, or it will start looking your layer 2 frame or your Ethernet header, and PANOS extract the source MAC and destination MAC from that header. Packet parsing start with layer 2, and guys, always when you PaloAlto start the packet processing, it will start from the layer 2 header. Then it will try to get the ingress port. If we are just receiving the packet with some VLAN tagging like 802.1q tag, let's suppose we have deployed firewall in layer 2 mode, right? In layer 2 mode, we can able to configure the VLAN and other things on your firewall, right? So it will check the VLAN tag as well to get the actual VLAN details. Destination MAC address are used as a key to look up the ingress logical interface in case of layer 2 deployment, guys. If interface is not found, the packet is discarded and the hardware interface counter receive error and the global counter flow receive.1q tag error will be incremented. And guys, how you will able to see these particular errors? If you will go into the firewall and you have to run this command, so counter global, this is the command, and here you will get all these type of error details. Like these type of errors counter will be increased during that time. Okay. Now, Mubarak, you can please write your question in a book. I will basically cover that part later. Okay, let me just focus on the packet flow because it's a big topic. If I will deviate from the topic, then maybe you guys not get 100%. Okay. And I like to explain you that packet processing 100%. So you have the entire idea. Okay. Now they will start the layer 3 parsing. In layer 3 parsing board, my PANOS, it will take the IP header, it will start parsing, and it will extract source IP and destination IP and IPv4 header. Let's suppose, because you know this layer 3 header, it can be a IPv4 and it can be a IPv6, right? Depending on the IP version. So let's suppose we are just using IPv4. So what a packet can be discarded for any of the reason. These are the header errors. Basically, it will check at your IP header. It will check mismatch of ether type and IP versions. So guys, when we will look your Ethernet frame, by looking into this Ethernet frame, we will get to know what is the layer 3 version we are using. Like we are using IPv4 or we are using IPv6, right? That information we will get from the frame or not. Generally, in Ethernet frame, we have a field called ether type. That particular field let us know the next layer version, like IP version. We have to use IP4, IP6. Let's suppose in Ethernet type, it is just telling the version is IPv6, but when my firewall did the parsing, he will found it's IPv4. It's a mismatch, right? So that type of packet is dropped by the firewall right away. So this is the first this is a first error which may occur in your layer 3 header. Truncated IP header. Truncated IP header means, guys, what is the size of IPv header? What is the minimum and maximum size of IPv4 header? Minimum is 20 byte and maximum is 60 byte. Let's suppose, and guys, these particular IP header has a predefined fields, right? It has a source IP field, destination IP field, right? It has a IP version field, fragmentation field, all of them. Let's suppose somebody has modified these particular fields, which is a problem, right? So if truncated means if some information has been removed from the actual IP header, these type of packet is dropped by the firewall right away. And guys, if your firewall dropping these packets, you will not able to see these these particular drops into this monitor or logs. No, you will not able to do that. You will not able to see these things in the logs. Okay, because logs comes when your packet is dropped by the security policies and other things. Okay, let's suppose we have received a packet with IP protocol number 0. If we are receiving these type of packets, what my firewall used to do, it will block the packet, right? It will drop that particular packet right away. Let's suppose I'm receiving a packet with TTL 0. Time to live value is 0 on the packet. These type of packet also firewall will drop right away. If on your packet, if source IP address equals to destination IP address, means source is same and destination is also same. In that case, firewall consider this as a land attack, and these type of packet is also dropped by the firewall right away. Then ping of death. Martian IP address. All these type of packets has been dropped by the firewall right away in your layer, in your IPv4 header. Then we have a IPv6 header, like mismatch ether type, truncated IPv6 header and truncated IP packet. These type of packet is dropped by the PaloAlto firewall in case of IPv6. Jumbogram extension and truncated extension header, these packets is also dropped by the PaloAlto firewall with regards to IPv6. And after that, it will do the layer 4 parsing or packet parsing. It will start at layer 4. In layer 4 generally, we have a TCP, we have a UDP, we have a ESP, we have a GRE, we have ICMP headers. And these are the main headers which generally you will see in the production environment at layer 4. In case of TCP, packet is discarded due to these reasons, like TCP header is truncated or modified. These type packet is dropped by the firewall right away. Data offset field is less than 5. In your TCP header, there is a data offset field, guys. And if that field is less than 5, what firewall will drop that particular packet as well. If, because you know in TCP we have a checksum, right? If there is a checksum error, it will basically drop that particular packet as well. If the port number is 0, it will drop that particular packet as well. If invalid combination of TCP flags, invalid combination means, can you able to see SYN plus FIN flag together? Can you able to see SYN and FIN flag together on a packet? No, that's not possible, right? So like if you have an invalid combination of TCP flags, it will drop these particular packets as well. And after that, it will start the UDP packet is discarded due to these reasons. UDP header truncated, UDP payload truncated, UDP buffer length less than the UDP length field, or checksum error. If they have these type of errors, they will basically drop all these packets. And guys, if your packet is dropping at the ingress stage, you will not able to see on the logs. That is correct, Mubarak. You will not get on the logs. There are the special commands you have to run to see these things. IP fragment reassembly if required. What it will do? If we have received the fragmented packet, what? IP fragment will be passed, reassembled by the defragmented process. So in your PaloAlto or in your PANOS, we have one process called defragmentation process. That process first do the IP reassembly, then fed back to the parser, and parsing will continue with the actual layer 3 IP header. A fragment may be discarded due to teardrop attack or overlapping fragments. Overlapping fragments means whatever fragments we have received. Let's suppose there are overlap, means some part of this fragment is available here and some part of that fragment is also available on the next one. This is the overlapping one. So this type of data is considered as a teardrop attack, and PaloAlto firewall going to drop that packet right away or discard that packet. If one of the fragment are missing, all the fragment will be dropped since packet cannot be reconstructed. Means let's suppose after the fragmentation, that packet is fragmented into 3 fragments, and when firewall receive, only he has received 3. These type of packet is also, these fragments is dropped by the firewall right away. Then ingress processing error. All the above thing comes under the ingress processing error only, guys. And now if you will go here, let me show you the parsing as well, how they used to do the parsing. So guys, now just put your full attention here. You can see packet received at the ingress stage. So guys, these are the actual logs, which like we have to run some advanced debug commands on the PaloAlto firewall to see all these processing. And if your packet is dropped by the PaloAlto firewall at ingress stage and all, this is the command which we generally use for the troubleshooting purpose. So what used to happen when we have received a packet, and as soon as we will receive that packet, it will go into the ingress stage processing. And in this, you can see we have, this is the length of packet, port number. So guys, your every interface like Ethernet 1x1, Ethernet 1x2, they have some port ID. And your Cisco devices also, you will get this port ID. Like, so let's suppose Ethernet 1x1 has port ID 16, then it has a 17 like that. Port 17, interface 17, virtual system 1. And after that, my PaloAlto firewall has allocated the work queue index. This is the work queue index value. And now it has just start decoding the packet. Means it will start the extracting the information. And as I have told you, it will start at layer 2. This is the source MAC. This is the destination MAC. And this is the ether type. Then it will start layer 3 IPv header processing, source IP, destination IP, layer 3 protocol number, IPv4 version is 5, IPv4 header length, toss field length is 52, ID, fragmentation, offset, TTL value, checksum value, all of them. This is your IPv header. And after that, it has a TCP. This is your source port, destination port. And after that, we have a sequence number. This is the sequence number, acknowledgement number 0, because in TCP SYN, we just have a sequence number. We only have a sequence number, and acknowledgement number is always 0. Result field offset is 8. Windows size, checksum value. These are the flags. And generally right now on the very first packet, SYN flag is set. Urgent data. And this is the 14 data length. And they have some TCP optional fields as well. And once, guys, this particular processing has been completed, you can see now firewall is doing the flow lookup. It is doing the flow lookup, right? Now let me, because now let me just move here. Let me just go into this one. So guys, now ingress error. And after that, it will check for IPsec and SSL VPN. So guys, this particular, this particular document released by the Palo Alto Firewall in 2010. It's a very, very old document. Okay. And the latest packet flow is happening on the firewall according to this one. Ingress process error. If there is any error on the packet, it will discard it. If there is no error in the packet, now it will forward this packet towards the DOS block table. Now it will basically check the DOS block table on the firewall. What is this DOS block table? Let's suppose somebody has launched any type of attack in your environment, like they have just launched the DDoS attack or IP spoofing attack, right? These type of attacks, if my firewall sees there is a attack is happening, what it will basically block these IP address and it will put these blocked IP address into the DOS block table. And if this IP address is a part of DOS block table, yes, then it will discard. If no, then it will forward this packet here. It will check firewall inspection applicable. If yes, then it will check for IPsec, SHS, SSL, VPN, GRE. If we are receiving the packet from these protocols like IPsec, which is ESP packets, SHS secure socket layer packet, like SHS secure cell, then SSL, which is your SSL VPN related packet, secure socket layer packet, or GRE packet, because your ESP, SSH, SSL, and GRE. What they used to do, these particular protocol, they used to hide the actual information, right? Actual header is, they generally used to hide the actual header. So what they used to do for these packets, if we are receiving these packet, yes, then firewall basically for IPsec ESP packet, what it will do? It will basically, in case of ESP packet, it will first check the hash. If hash is matched, it will allow the packet. If there is a mismatch with the hash, it will drop the packet right away. Then after the hashing means hash check means it will validate the integrity of the packet. And when I will discuss the VPN, that time this thing will be clear. Okay. Then after it will decrypted the packet and it will do the decapsulation. And once it will do all these things, they will get the actual IP header. Now this actual IP header, it will send again towards the ingress processing. If we are receiving the SSL VPN packet, what? They will check the hash. They will do the decryption and they will send this packet towards the ingress stage check again. For the GRE, they will do the hash check, they do decapsulation, and they will send that packet towards the ingress check. Now guys, let's see how this particular DOS block table looks like. So if I'll go here, if I run this command, debug data plane, show DOS block table, and you will see right now I don't have any IP on the block list. So what I can do, let me just launch one simple attack from my Kali Linux machine and we will see how this particular firewall is maintaining the DOS block table. Because this is a something new information, so I will just launch the using the nmap utility. I am just launching the IP spoofing attack. Okay, and all the configuration already there. And when I will show you the DOS, like your DOS protection and your zone protection lecture, that time you will get to know all of them. Okay, but here my intention just to show you the content of the DOS block table. And right now you can see it has just created the DOS block table and this is the IP address because I'm launching the attack from that IP address. So guys, what it will validate this particular table here. If you think this is a legitimate traffic, you can also able to clear the things. If you will run this command reset DOS, you can able to reset that particular table as well. And this will not impact anything. This is just a normal show command. Okay. It will not impact any type of CPU, nothing like that. It's just a normal show command. Cool. So guys, this part is, I have proved this part. It will check this particular table. We have seen this table as well, right? Because you know why I'm trying to explain this part again and again, because you know this information is not there into this particular packet flow. That is the main intention here. Okay, just remember. And after that, let me just stop the attack, because attack is still going on from this machine. Now guys, what it will do, if you remember from here, because we have initiated the traffic, we have initiated this traffic from this source. Or let me just go here. I will basically, I'm using multiple steps here. So guys, because you know I am initiating the traffic from this source 10.1.1.70. I'm sending the packet towards this server. So guys, just tell me one thing. What is the packet format looks like here? 10.1.1.70. This is the source IP. Then we have a 151.7.1 destination IP. Then we have a source port 1025 hypothetical and the destination port 443. And guys, also tell me one thing. When this particular packet reaches to this firewall, so what this firewall will do, it will extract your layer 3 information, right? Means your source IP address is extracted. Your destination IP is also extracted. Then your source port is extracted. Your destination port is extracted. And guys, in ingress stage processing, my firewall did the ingress zone lookup. He has the details of your source zone or not. Here we have a detail of source zone which is inside. And we know the layer 3 protocol number, right? For TCP, which is 6. And if you will see, these are the 6 tuple of my session table or not. These are the 6 tuple of my session table. So what my firewall will do now, it will basically run the MD5 hash on that. It will get the flow key here. It will get some value here. It will get the flow key. Now using this flow key, what it will do, it will do the perform the lookup into the session table. Guys, because you know, is there any session for this particular first packet? Is these particular, there is any session for this particular session? No, it's just a first packet, right? So guys, what it will do now, my firewall, it will use this flow lookup and it will perform the lookup into the session table. In session table, that particular table is stored actually into the MongoDB database. It will do the lookup into this database, and it will generally, it will not found any session, right? Now you can see here, you can see it is not able to found any session. It did the flow lookup. You can see these are, this is the flow key it has used. You will see this type of number. You can see, is there any type of session? No. There is no active session. The one person has asked how it will do the lookup on database. It will basically run the query, man. Okay. It's not a database class. Okay. It will use to do the lookup in the database. Like it will use maybe SQL query, whatever. Don't care about it. Okay. So right now there is no active session. So you can see no active session flow found in queue to create a session. It is sending this packet towards in queue to create a session. And you can see now packet received at the slow path stage. So if there is no session, packet will be always go into your slow path, which is or your connection setup state here. Firewall session lookup, session match. If yes, then fast path. If no, then slow path. Firewall session setup or slow path stage. Now in this stage, what is going to happen? So I will not refer this particular diagram here, guys. I will refer the latest one. Okay. And guys, remember one thing. Firewall failure lookup match by using the 6 tuple extracted at ingress stage. And guys, all these 6 tuple it has already extracted. Okay. This time there is no flow. No flow means it will go into the session setup state, which is slow path. Okay. Now in this slow path, before going to this slow path part, guys, let me just cover one more thing, because you know this thing definitely you will get in the interview. So guys, generally what is flow key? Flow key is a hash of 6 tuples. We have a 2 flows, client to server, 1 flow key. We have a server to client, 1 flow key. And guys, just tell me one thing. It's just a general question. For TCP, in TCP, we have a field called source port and we have a field called destination port, right? And they are using this source port and destination port field, like they will include it into your 6 tuple for creating the keys, for creating the flow key, right? These are the part of your 6 tuple information. For UDP also, in UDP header, we have a source port field and destination port field, right or not? But about the ICMP, in your ICMP header, do you see any type of source port or destination port field? I hope guys, you know the ICMP header. Do you see any type of source port and destination port field for ESP header? Do you see any type of source port and destination port field for GRE packets? Now, how my firewall is going to handle, how it will basically create a 6 tuple information for ICMP, for ESP, for GRE packets? Because in any your interview, they are going to ask this thing. I got answer from Maninder on the basis of IP address. Guys, try to write some legitimate information. Okay. Do not guess. Guessing will not work here. Okay. If you know that is good, you can write at least like 20-30% correct answer. Okay. Now, let me just go here. ICMP header diagram. Oh, it's very bad. It's not coming properly. So guys, in your ICMP header, if you will see, this is not the correct one. ICMP header, where is that one? Type code, checksum. This is the one. Let me open into the new link. This is also having the correct information. Okay, so guys, if you will see this diagram, this is the header of your ICMP packet. So guys, in your ICMP packet, what it used to have, it has a two field called identifier and sequence number. So what used to happen, it will consider this identifier as a source port and sequence number as a destination port. It will use these identification identification number and your sequence number, or identifier or sequence number, these two things from the ICMP header. Your firewall use identifier as a source port and a sequence number as a destination port. Now guys, are you able to answer this thing if somebody asking? Yes, no on the chat? Because this question you will get, definitely you will get, because this is the question asked by the interviewer. TCP, UDP, everyone know, but ICE, they will just ask some tricky question. Okay, now let me just ESP header. Let me look for some good ESP header diagram. Okay, now in this ESP header, guys, how it used to do, generally for IPsec packet, who has maybe worked with the VPNs, they definitely know SPI numbers, SPI in, and they may also know SPI out, SPI inbound and SPI outbound, inbound and outbound, right? Service parameter index. And your ESP header has a this particular field called SPI field. So your PaloAlto firewall going to use this SPI number. It will use this SPI value as a source port and as a destination port. Just remember. So for IPsec ESP packets, how it will get the source details and destination port detail by looking into the SPI numbers. Now, let's look for the GRE header. In GRE packet, basically what we have, there is a one field called caller ID. And they are going to use that particular caller ID field for GRE header. I'm not able to get the proper details. In case of GRE, what they will consider the caller ID or call ID as a source and destination port field, guys. Just remember. Okay. You have to just remember these parts. No. And also one more thing, just remember, guys, when PaloAlto firewall create a session, every session have a lifetime. Like it, every session has a stage. We have a init, opening, active, discard, closing, closed, free. And where, guys, in your PaloAlto firewall, you can able to see init, active, and discard. Only these three stages is available, or you can only able to see these stages. Remaining stages are the transient state. Transient state means they are there for the frequent of the seconds. So you will not able to see these particular stages, but most of the time you will see discard, active, and init. Init means initialization stage. Now, let me just go back here. Let's try to move here into your slow path or session setup stage. Now in session setup stage, if you will see, the very first thing which is checked by the firewall is your zone protection profile. Means if we have configured any type of protection into the zone, it will check the zone protection profile. And it will also check the TCP state check. These are the two checks it is going to perform here. Zone protection profile and TCP state check. What is the state of TCP session? And what for zone protection profile? It generally use two things: randomly drop, or it will use the SYN cookies. These are the two methods it will use. And this zone protection profile protects us from the TCP flood attack, UDP flood attack, ICMP flood attack. If someone is trying to launch any type of IP spoofing attack, so such type of attack prevention you will get with the help of zone protection profile, or IP spoofing attack. That protection you will get from the zone protection profile. It will check for the anomaly or error on your packet. And after that, it will move further for the next check. And here it is going to check the IP to user, IP user, or user to group mapping. Means it will check for the IP, use IP to group mapping, or user to IP mapping, this one. So user, IP user mapping, all. It will check this particular mapping. Whatever the user to IP cache you are having, it will basically check that particular cache. Okay, just remember. No. So guys, your user to IP cache, it will check in your silo part to get the actual IP, actual user who is basically holding the IP address. Why it is basically doing that lookup here? So it can enforce the user based security policy, because you can able to configure the user based security policies. Mean you can block some traffic for some user on the basis of username. Now you don't need to block everything using the IP address. You can block using the username, because you know in production environment everyone needs to log in with his ID on the workstations. Now they can able to restrict, like for HR people you will give the access of appropriate websites. You like for your IT people you can give the appropriate access. For sales people you can give the appropriate access, right? These type of things you can able to control with the, and if you have these type of policies, that user to IP enforcement happens here. And this enforcement is only happened if you have enabled the user identification on your security zone, or on your ingress on that particular zone. If that thing is enabled, then only it will do the user to IP mapping. Okay. And how it is getting this user to IP mapping? We have to configure the user ID. We have to create a user identification configuration on the Palo, and I will cover that part in your later classes. Okay. But as I have shown you, it used to create this type of mapping, as we can see here. And let me just show you one more thing. If let's suppose I have this PC, because this PC is a part of my domain. If I will log in into this PC, let's suppose the username I will use here, Hemu. Password is admin at 123. And I will use my company details here. And if you will see here, this time binding will be there for Hemu. This is the IP address of Hemu, and this is the username of Hemu. And how will I get this detail? I get this detail via AD server. So it will check for this particular mapping. Now, after that, it will move further. Now it will basically check the very next thing, which is application cache information. Because in your silo path, firewall try to do the lookup into the app ID cache. Because why it will do the lookup into the app ID cache? Because your firewall, it used to maintain the cache detail for applications. Why it is maintaining that detail? Because if we will get the detail of application from here, then we don't need to send that packet to the app ID engine. If we know the application, then we never send that packet again to app engine. So to offload some load, or to enhance the performance of the firewall, they have added this particular app ID concept here. And let me just show you one thing. I'll go here. So DOS block table, there are some commands I have written. Tunnel decapsulation they used to do. For IPsec, they do the hash validation, decryption, decapsulation. And I'll share this particular diagram so you don't need to worry about it. Then flow lookup. Then silo path, zone protection profile check, SYN cookies. All these things we will discuss, so you will get the idea, like TCP state check, TCP state for inspection enabled, non-SYN packet for new session will be discarded right away, right? All these things. And we can also able to control that part. We can able to basically disable that behavior. What is the meaning of this TCP state check? I think I have not explained you the much thing on this. TCP state check means, let me just show you one thing. Let's suppose I have this diagram. I have this PC here. We have one router here. We have firewall here. And after that, we have one more router here. This is R1, then this is R2, and we have one server here. And somehow this R1 and R2 also have a connectivity like that. So what happening when this PC is sending any traffic? This traffic is going on R1, then it is going towards the firewall, then it is going towards this R2, then server. And after that, what is happening? Or let me just explain you in this way. PC initiated first packet, and first packet is always a TCP SYN packet. And now TCP SYN took this particular path. It reached till R2, and after it will reach till this server. Now when server give the reply, in reply he will send SYN plus ACK. Now my firewall is receiving here what? SYN plus ACK. And instead of SYN, he is receiving SYN plus ACK. So this packet by default it will drop. But you can able to disable that behavior. If you will run this command, it will basically start accepting these type packets as well. And this setting you needed, or these type of packet, you will see if there is a asymmetric routing in the environment. If we have a asymmetric routing environment, in that case only these type of packets you will get. Like, because if you have a two paths, in one path firewall bypassing, firewall is bypassed, in second path firewall is in inline. Okay. So TCP state check means it will just check for that, and you can able to disable these things. We have the commands. You can run this command. This command will disable for temporary. You can want permanent. You can do with that. Okay. Then it will check the IP or user cache information. Then your application cache, and how it will do the application check. So if you will run this command debug data plane, so running application cache, this is the command which will show you what is the cache information we are having here. If I run this console application, not like that, so running, and when we will add so running means we are looking the details in your data plane application cache. Right now you can see I have a list of these application, and because these are not a legitimate ones, so what I will do, if I'll go here on my inside PC, if I'll open this browser, let me just try to access the facebook.com and you will able to see the details. Let me try to open Netflix as well. Now I have one mapping only, but it will, I'm not sure why it is not able to communicate over the internet. I know why it is not able to do that, because on my firewall looks like I have the wrong routing. Because I was using that because right now I'm on my native, so I have basically I'm getting some different IP address on my router. That is the main reason, because my default gateway was wrong here. I have to basically change this with 192.168.1.1. Now things will work. Let's wait here. So guys, are you getting the things what I'm trying to explain? Because packet flow, if you will know that packet flow in detail, you can able to troubleshoot the issues actually. At least you will able to understand where my packet is going and what's happening how when my pan OS is doing the packet processing. Let's wait for this commit to complete. Meanwhile, so guys, these are the command: debug data plane, reset app ID cache, but it will delete the app ID cache. So running application cache, it will basically show you the application cache information. Set application cache, no, it will basically disable the app ID cache feature on your firewall. This will enable. So running application cache, this will show you what is the setting right now you will be having. Because guys, in your this diagram, we don't have anything with regards to app ID cache, no zone protection related info here. Why we are not having that information? Because it has a little bit, because this is a little bit old diagram. Okay, user cache is information is also not there. This time if I'll go here, if I will open Facebook, if I'll open Netflix, ping is working. I have I think Netflix is blocked. What about the Facebook? It is also blocked. For user Hemu, right? It is blocked for me. I was doing some tests. That is the reason. Now you can see I have the details, right? This IP address belongs to Facebook, and this IP address belongs to Netflix. Okay, just remember. And here you can see it will basically put the destination IP address, destination port detail, and your layer 3 protocol number. This is your layer 3 protocol number. These are the three values. Generally, it will store into your app ID cache. Look, let's go back here. So when it will do the lookup for app ID cache, it will do the lookup on the basis of destination IP, destination port, and protocol. Now, you can may ask one question, how this thing is helping the PaloAlto firewall. Liaquat, actually, why you are asking the question from the out of the topic? I was not discussing man URL filtering and all, right? So please stop asking these type of questions. You can ask from the topic actually. Okay. Can we block only using URL filtering? Because there are lots of people who they don't know URL filtering, how it works. They don't know the what is app ID, how this app ID works, right? So if I will start explain these things, no one able to get. And I don't want this particular session as like a discussion room actually. Okay. So let me tell you how this feature helps. Tell me one thing. Let's say we have a PC1 and we have a PC2 and we have 1,000 more PCs. We have a firewall here. And all this traffic going through this firewall, let's say they are accessing one common application. Let me just give the name like Outlook. This is just one of the common application. Now, tell me one thing. When PC1 access this outlook.com, all the packet or the packet of PC1 will go through with you with the app ID or not? First answer this thing. Guys, because Outlook is a HTTPS website. So this particular packet from PC1 will go through this app ID, processing app ID engine, right? Now when PC2 will access the same application, this particular packet will also go, the packet from PC2 will also go through the app engine. When the remaining 100,000 people, they will access the Outlook application. So every user's traffic is going through the app engine again and again, right? For the same application. So what they used to do, because my firewall create a cache. So if one person has access that application, remain for the remaining people, because it has created the cache information, and now your app ID information they will get through the silo path itself. They don't need to forward the packet on app ID for the remaining particular peoples. So that is the benefit you will get. Vivek, like either you can use web browser or you can use mobile app. Always you are going to access the app server only in a backend. Okay. Just remember, in a backend, it is always a app server. Now, and after that, now this packet move further for the next check, which is a forwarding lookup. Forwarding lookup means now they do the lookup into your routing table. The main purpose of this forwarding lookup is to get the egress interface detail. Now they will try to get the egress interface detail. They will try to get the egress interface detail. Now let's try to understand this. So guys, there are two things. Do you guys have any idea about the PVR? What is the main purpose of policy based routing or PVF, policy based forwarding, because both are same? Anyone have any idea on these two things? This is the time. Liaquat, you know, like what is PVR or what is PVF, or anyone? Yeah, Liaquat, you have answered correctly. Like it's a source based routing or a decision making precedent over the static route. So PVR will take the precedent over all the route. It's not about the static route. So generally what used to happen, this PVR or PVF, what we will do, it's a policy based forwarding in PaloAlto firewall. Means generally when any device doing the lookup into the routing table, when any device will do the lookup into the routing table, what they generally used to do, they used to do the routing lookup on the basis of destination IP address. Just remember, they will they will do the lookup on the basis of destination IP address, and they will try to get the egress interface. Okay, but what used to happen, let's suppose you have configured the PBF, policy based forwarding. In a policy based forwarding, this PBF will allow you to do the egress interface decision on the basis of defined rule set. If you have defined in the your rule, if traffic coming from this and going towards 8.8.8.8, this is a destination, and a port number, let's suppose like layer 3 protocol number is, let's suppose 6, or let's suppose destination port is 80. Just send this traffic through this interface, means we are defining the egress interface now. So guys, if we have a route, if we have a PVF, then what it will do, my firewall take the decision, or it will basically, it will get the egress interface details on the according to the policy based forwarding rule. If we don't have PVF, then it will do the egress interface decision on the basis of routing lookup. In forwarding, if you will see, to get the egress interface or zone detail on the virtual system, they will do the L3 route, means they will do the lookup on your L3 routing. For if we have deployed firewall in L2, then they will do the lookup into FDB lookup table, or they will do L2 FDB lookup. Okay, now let me just explain you this thing correctly here. So forwarding lookup, they generally do to get the egress interface and zone detail. For first packet, as per the interface type, the forwarding lookup stage determines packet forwarding path. Packet forwarding depends on the interface type. Let's suppose we have received the packet on layer 3 interface, then route table lookup is used to determine the next hop. If the same subnet, then ARP table lookup is used, means if the subnet is same, means let's say source is 10.1.1.70 and destination is 10.1.1.80. Then they will do the lookup into the ARP table. So if we have a policy based forwarding rules and we have a FIB, so generally guys, your routing table, we have a routing table. In actual, your firewall or any routing, any device, they will do the egress interface decision on the basis of FIB, forwarding information base. Like in Cisco devices, we have a CEF table. So we have a FIB table, forwarding information base, because in routing table, you have a multiple routes, like you have a, maybe you have a route for same subnet, which is pointing towards two interfaces, right? But in FIB, you have the actual interfaces defined. For layer 2, egress interface for destination MAC is retrieved from the MAC table. If information is not present, frame is flooded to all the interfaces except the interface in that particular VLAN. If we are having virtual wire, egress interface is peer interface configured in the virtual wire. No additional forwarding lookup is done. In tap mode, egress interface or zone is same. Ingress interface and zone packet is discarded. So guys, generally, now I think you have the clarity here. We do the routing lookup, we do the forwarding lookup to get the egress interface and egress zone details. If we have a policy based forwarding PVF, then they will make the decision on the basis of PVF. If we don't have PVF, then they will do the lookup into your FIB table, forwarding information base. And let me show you what is FIB table. If you will go here, if you run this command, show routing route, this is your routing table. This thing is known as a routing table. If you run this console routing fib, this is your fib table and your actual decision is done by this particular table. Actual decision is done by the firewall by using this particular table, just remember. Okay. And after that, guys, once your routing lookup will complete, now your firewall, or before that, here we have to also discuss one more thing. Tell me one thing. Now they will do the net policy lookup. Here they will just do the net policy evaluation. Here they just try to do the net policy evaluation lookup, but they will just do the evaluation means what? They will try to identify this is my net rule. Okay. They just get that detail. This is my net rule, like index 1, index 2. This is the net rule which I am going to use according to the net rule configuration. So guys, what happens? Let's suppose if your traffic is matching the destination net. So what will happen? Let's suppose my destination is this 10.1.1.70 is my source IP address, and my destination IP address, let's suppose 151.7.250. This is my destination IP address. When if there is any destination match happens, what will happen? This IP address will change or not? Guys, your destination IP address will change or not? What do you think? Right, when my firewall do the destination net translation, your destination IP will change. If your destination IP will change, then what will happen? Because here when we did the lookup in your forwarding table, we get the egress interface like Ethernet 1 by 1 is the egress interface that time. That interface we will get during the routing lookup, and that lookup we will did on the basis of destination IP, right? But now destination is changing because destination net match happened here. What it will do, if your destination if there is a destination net, yes, then I will send that packet again for the routing lookup, and this time my PAN-OS do the lookup on the basis of new destination IP address on which that IP address got translated. Because maybe for the new destination, maybe that new destination is available behind any interface, right? It can available behind any interface. So they will do the again, it will do the lookup into the routing table. In case of destination net, just remember. And after that, they move further. And let's suppose if there is no destination net, if it's just a source net, and if it's just a source net, then your packet just move further right away. Net policy lookup, if destination net is present on the match rule, do the second forwarding lookup to get the final egress interface. If it's just a source node, they will move further for the next check. Now let's try to see what is the next check. Now the next check is your authentication policies. Authentication policy lookup. But let's suppose you have configured the captive portal. Captive portal thing we used to configure for the contractor type of user. So before they will able to access anything through your network or through your firewall, they just validate their identities. So what if you have configured the captive portal? What will happen? These authentication policy will trigger. And guys, all these policies are here. If you will go into the policy tab, These are the authentication policies here. Right now, I don't have any, but from here, they will trigger this particular thing. Your PBF is also here. Your PBF will trigger from here. Okay. Now, and once your authentication policy, if they we have configured, then only they will trigger. If no, then your check move towards the next thing. PanOS will start checking next thing, which is DOS protection policy lookup. Here they will do the lookup for the DOS policies. And when they will do the lookup for DOS policy, they will use the pre-net IP address and post-net zone. And so the guys, there is a concept of pre-net IP and services, and there's a concept of post-net zone. And that thing I'm going to explain in your net session. Okay. So for now, you can think about it like they will check your DOS protection policies. And if we have any DOS protection policy, like if we have configured any DOS policies, it will try to enforce these policies. DOS policies is almost similar to your zone protection, guys. Okay. And after that, it will move towards the next thing. Like in DOS policy, we have a two type of policy generally: aggregate policies and classified. Aggregate or classified threshold. If yes, like if any traffic matching the DOS policy, if there is a violation, then it will basically block it. If no, now your packet move further and they will basically check the security policy lookup, or they will do the security policy lookup. Now in this security policy lookup, what they will check, they generally use the pre-net IP address and port numbers and post-net zone. Pre-net IP address means your, or how I can explain this, but like, because you know this pre-net concept you will get when I will discuss the, when I am going to discuss the DNet. Okay. So the thing is, uses pre-net IP and port numbers, post-net zone details. They will think application as any, URL filtering category as any, and then they will start parsing the rules, and they will start looking the rules. And guys, the rules lookup start from top to bottom. Means whatever rules you have on the top in your PaloAlto, these rules got processed first, then it will do the lookup towards bottom. If you will go here into security policies, they will start the security policy evaluation from top to bottom. They will check first rule. If match happens, then they will stop checking. Then they will move. If match is not happen, then this one, then this one, this, like that. They will move further. That's how they used to basically do the this particular thing. Okay, security policy lookup. I got lots of, like, I got question on two people. How do you guys digest? It's up to you guys. If you will not able to digest, you can skip, right? Because you know, I'm explaining step by step and you guys needs to digest. That's how you will able to crack the interview, right? Now, if guys your traffic is matching any rule, and let's suppose on that rule, if we have set the action deny, in that case, that packet is discarded. And guys, if your security policy is discarding any packet, you will get that detail into the log, into the monitor tab of your PaloAlto firewall. So your log will be generated, and this log will only be generated if you configure log at the session start or log at the session end on that particular rule. Otherwise, it will not generate any logs. So guys, if like you are not able to get the information on the log, you don't need to say like, you don't need to say to your customer there is no issue on the firewall. Maybe your maybe the packet is dropped at the ingress stage, maybe packet is dropped by the zone protection, DOS policies, routing, multiple things are there, right? And if let's suppose your security policy action is allow, then what will happen now? PaloAlto 5 will create a session and it will install the session into the session table. And here guys, what? Here it will create a session, it will install the session into the session table. It will create client to server flow and server to client flow. And it will store that information into the session table. Because in PaloAlto firewall, all it has a capacity. Let's suppose your fire device has a capacity of 64,000 sessions. So because all these session IDs generally available into the free pool. All the session ID is a part of free pool. And if your firewall is allowed the traffic, then what will happen? One of the session ID, your pen will take out from that free pool. It will allocate that session ID. Let's say session ID 100 is allocated. And with this session ID 100, client to server and server to client, these two particular flow key is associated. Because this client to server, all that information we will extract it into ingress stage, right? For server to client only, we were not aware about the zone details. And because by looking into the routing table, we have the zone details. So we have all the information to create both the flows, server to client and client to server, and they will install that particular session. And if once this session is created and installed into the session table, now they will basically check the tunnel inspection policies or your TCI policies. Because nowadays, if you will see, there are some application who is supporting the layer 4, like 4-layer encapsulation or 7-layer encapsulation, right? Means we have a actual header is hidden inside 7 layers of any other headers, right? So all these things they will basically parallel to get from the TCI policies, tunnel inspection policies, like protocol like GRE, GTPU, IPsec, non-encryption, VXLAN, all of them, TCI related policies. And after that, guys, what will happen? Now, till this point, your silo path has been completed. Once your silo path is completed, if I'll go here now what used to happen, if you will go, your session is created and installed into the session table. And after that, you can see this pointer came into the layer 2 to layer 4 packet processing or firewall processing. Okay, so one session is installed into the session table. Flow session is in session table. Now what here also they will verify. If that session ID is in free state, then they will discard. If session stage is opening, discard, or active, they will reset the default timeout for like TCP, UDP, and ICMP. And what they will basically put that particular, and after that your cursor move towards the fast path, which is also known as security processing or layer 2 to layer 4 security processing. Now in this layer 2 to layer 4 security processing, what they will do? They will apply the net. So guys, in the silo path, only net evaluation happens. Actual IP translation they will apply here. Apply net if applicable. And again, they will do the forwarding lookup for all client to server and server to client packet. Now, why they are doing the lookup again? They used to do the lookup because when reply will come from that server, how my firewall know where he has to send that reply? For reply packet, they will do the forwarding lookup. There is no route, then that session will be discarded right away. And after that, that packet move here for the SSL proxy. Generally, if your firewall is doing the, if we have configured the SSL proxy. So with each and every session, there is a one flag which is associated for SSL proxy. So if SSL proxy flag is in session, if yes, then apply the decryption if applicable. And SSL decryption, this thing is applied when we will configure. Okay. And after that, it will move further. Application identification in the session. Means now they will, if if my PanOS know the application of the session. If no, if yes, if my firewall know the application, then it will move for your layer 7 inspection for content engine. If my firewall don't know the application, now it will send this packet through the app ID. In app ID, this is the app ID related information. In app ID, what? They will check the application override policies. There are the application override policies, and we can able to configure these policies to bypass the app engine for some internal applications. Okay. So if your application is a part, if like we have configured the things, whatever like app override policy we are having, if this policy is matching, then your panel is reached here, like enforce the security policy with that application. Security policy look up with that application, they will check rule match action. If action is allow, yes, then security profile configured. If yes, then they will send the packet towards the content engine. If no, like rule, like if we have an application based rule, then that packet gets discarded right away if the action is denied. If your traffic is not a part of app override, then move further and it will do the pattern based application identification. And here your actual app identification happen, means pattern based application identification will happen. And if application is identified, they will update the application cache. Then they will enforce the security policies for that particular application. Now go a little bit here. Now your if layers and like apply security profile flag on the session. So what do you has to happen, like if on your security policy, if we have enabled the layer 7 security profile, if that profile is enabled, then only your packet will go inside the content engine, and that particular flag used to add with that particular session. Okay. And after that, they will also check the quality of service QoS policy lookup. And also one more thing, guys, let's suppose if your application is identified as SSL, secure socket layer, or SHS. If yes, if your application identified as a SSL or secure, say if yes, then they will forward towards the decryption policy lookup. Now they will check the decryption policy, because we were only able to decrypt the traffic for SSL and SHS protocol. If decryption rule is matching, like match decryption exclusion cache. So guys, there is just one exclusion cache, like we can able to exclude some traffic from the SSL decryption. If yes, then this packet go towards the layer 7. If no, now this particular packet again go into your fast path for the SSL related SSL decryption related things. Okay. Now we have a content engine here, CTD. This is your content ID, your URL filtering, antivirus, all these things applied here. So like if CTD flag or layer 7 enabled in the session, then they will move further. And here what they are running some type of decoders and other things. They have some application decoders here, because tell me one thing, let's suppose I have identified application as Facebook base, and now on my session they have written this particular traffic belongs to Facebook base. So guys, if application is identified as Facebook base, do I send that packet again or the remaining traffic again through the app engine? No, right? Because application is already identified. Now let's suppose suddenly there is a person who will start using the Facebook chat. So how this application shift will detect by the firewall? It will detect with the help of these particular decoders. Application shift yes, then this packet go in the app ID again. If no, then threat detected. Threat means if your traffic having any type of malware. If threat detected yes, then apply the security profile action. So if we have action like drop, reset client, reset server, reset both, then they will discard. If we have action like alert or allow, in that case they will allow the traffic. If threat is not detected, they will send packet here. And if we have applied the SSL decryption, if your SSL decryption is applied, we have to re-encrypt the traffic. What we will do the re-encryption of the traffic, and after that we will forward this packet towards the packet forwarding stage. So this is the egress of forwarding stage. Now in the packet forwarding process stage, use the ingress interface to get the forwarding domain, do route, do switch. What, like if we are having like, it's if we have received the traffic on layer 3 interface, then we will do the route lookup and your ARP look and L3 lookup and your L2 lookup. We will create a new IP header. We will form all the packet and everything, and after that we will forward. If let's suppose we have deployed firewall in vwire mode, then they will send out the packet through the another interface. And if like packet egress processing, apply the deep fragmentation if needed, apply the quality of shaping. If we have configured QS, then they will basically apply the QS shaping if we have configured. Ingress to the tunnel interface. If your egress interface is the tunnel, then if it's a IPsec VPN related traffic, then they will do the encryption, they will calculate the hash, and they will encapsulate. For SSL VPN encrypted, has added. For GRE has added and encapsulated. And after that only they will forward this packet through the egress interface. So that's how the packet flow of your Palo Alto firewall. Like in app ID, as I have mentioned, check the app override policy, do the pattern based application identification, enforce the security policies for that application. If rule match, if action is allowed, yes, then move further. If no, then discard it. Now they will check for the content inspection setup, application SSL and decryption policy match. If yes, then forward this packet again into the fast path for the SSL decryption related things. And when your packet reached here into the content engine, they will do the scan, they will check, they will run the procode parsing, decoding, content matching, all of them. Application change from the content inspection. If yes, means if there is any application shift, they will send the packet again into app ID. If no, detection result from the inspection, apply the security profile action, apply the decryption if needed, and they will do the packet forwarding like that. Now, let me show you same thing, guys. Let me just also check one more time if I have anything here as well. In fast pass. So guys, if you can, what you need to do, you have to check this particular document. Just go through with this document. Here I have written all the step-by-step process. Okay, all the step-by-step process is there. I'll put that particular document with everyone. Okay, don't worry. I'll share maybe after today's class. Now, let me do one thing. Even though this document is also very good, I have found this document will also have the information. The main problem with this document because this is an official document from Palo Alto, and I think it's a very old one. I can see the date and other things as well. Like they have done the division on 2005. Okay, cool. Now, this guys, give me 1 second. Only 1 second I need. Okay, cool. I hope guys I'm audible properly. Just confirm yes, no on the chat. Let me just go through with that part and this one. So guys, well, actually, as you know, as I have told you, your TCP SYN processing used to happen like ingress stage, flow lookup, slow path, fast path, forwarding stage. Now, if you go here into this particular, because this is the actual packet processing, packet we have received at the ingress stage. It's just a SYN packet, right? You can see it's a SYN packet. For SYN, we don't have any type of active flow in the flow table. So it will go into your silo path. In silo path, basically, it has used all that particular information. 1 minute. It will use all that particular information which it has extracted. Now, session setup, it will do the PVF lookup if there is any. It will do the net policy lookup, DOS policy lookup, TCI inspection, allocated new session ID. This is how it will do the allocation, right? Net tool, which net tool it is matching. It will make the, it will just put that detail here, right? It will put the index detail because every net tool they have the index. If you run this command, set CLI config output format set configure. So running. So rule set. Exit. So running net policy. You can see these are the net tool, and every net tool had this index number, right? So they will just write this index number, which net tool they are matching. Okay, that's the evaluation process. They have this index number and other things here. And after that, this is how they used to do the translation. So they will put the source translation detail as well. Then created session, in queue to install the session into the session table. And after that, your packet go into the first path. This is the guys actual how like TCP three-way handshake happens, because here I have written TCP SYN packet processing. Now your packet reach into the first path. IP checksum valid, net session. Here it is just running the address translation, port translation. Pan flow process first path. Now your packet is going into the first path. It did like L3 mode, router is this. This is the forwarding lookup. This is the egress interface, port ID, route lookup, route found, right? All these things, ARP lookup it has done, and translate the packet on the port ID, which is 16. And this is how it will do the processing for TCP SYN plus ACK. Ingress stage. This time there is an active flow in queue to first path, and your packet is directly going to the first path. It is bypassing the silo path, right? So we have proved that if there is a session, then it will always go into the first path, and it is going, right? You can see. And how you will validate? We are looking the correct information. There is a way. Let me just do Control C, Control A. Let me go here. TCP send packet processing. Then we have a ACK packet, because if you will highlight this sequence number, because sequence number is similar for entire packet, and this is the same sequence number. This packet go directly from ingress stage, because this is ingress stage, it is going towards the first path. Then your forwarding. Here your ingress stage, this is ACK packet. Then your first path and your forwarding. Then client hello. Your ingress stage, your first path, and now you can see it is going inside the packet 9 packets resequence. Right now it is going towards the SSL engine and other things. You can see now it is sending that packet through the pen URL cache and all these things. These are the app ID and content ID related information. And after that, we have received the packet into the forwarding stage. Then these are the URL filtering logs. How the PaloAlto 5 going to do the URL filtering, everything is there. Okay, so that's how your packet processing used to happen in your PaloAlto firewall, guys. So guys, I think now everyone able to understand this part, right? How when there is a communication between this PC and this firewall and this server is happening, how the traffic flow and how the things are happening. Let me just explain you with the help of one more diagram, guys, so you at least got everything, because my main intention is to explain you all the things here. Let me just tell you again the same thing. In ingress state, we used to receive the packet. It will detect and drop the packets with the errors, detect and block the pre-session packet based on the, if there is any attack is happening, they will block these type of packets as well with the help of DOS block table and all. Then we have a silo path. They will in silo path generally what they will do the zone protection profile check. Then they will do the lookup into your app ID cache. Then your user to IP cache. And after that, they will do the lookup into the routing table, then net table, right? And after that, you can mention like user based policies, then DOS policies, or user or authentication policy, then your security policy, and after that, your TCI policy, tunnel inspection policies. Then we have first path, they will perform the net and decryption, perform session based DOS protection, check and apply the security policy rule. Then app ID, they will try to do the application identification, content inspection, they will scan the layer 7 data for any type of threats, any type of malwares, any type of like antivirus and any type of virus and other things. Egress, they will apply the quality of service QS thing, and they will send out that packet through the egress interface. Now, in this diagram, you will see in ingress stage generally they will do the error check, source interface and source zone lookup, and BPN decryption if we are receiving the BPN packet. In firewall session setup silo path, they will do the routing lookup to get the egress interface and egress zone. They will evaluate the net policies. They will basically enforce the user ID based policies and user to IP map policies. They enforce the security policies. They enforce your DOS policies, right? They will also enforce your tunnel inspection policy like TCI policies. For existing session, it will go into the fast path. layer 2 to layer 4 firewall processing, and SHS proxy decryption. If there is a web convey SSL decryption, then your decryption will kick in here. Then app ID, your app override policy, your payload inspect, for the security policies again for the application. Then content ID, apply security profile, and do the SSL re-encryption if we have did the SSL decryption. Then forwarding stage, keyword shaping, VPN re-encrypt, and net applied. Generally, this is wrong. They will do the net application here because I get this particular packet flow detail from one of the internet diagrams, so maybe information not correct. Then let's see what is the third thing we are having. If you will see this thing, you will get the same detail. We have received the packet, extract layer 2, layer 3, layer 4 information, do the error check, get the ingress interface and ingress zone detail, right? We will perform the DOS block table check. We will do the error check. For IPsec SSL VPN lit traffic, we will apply the decryption. We will send the actual IP header again for the ingress check, and we will send this packet for the session matching. And they will try to match the session on the basis of unique 6 tuples: your source IP, destination IP, source port, destination port, your protocol number, and your ingress zone. And we have a 2 unidirectional flows, one from client to server and another one from server to client. If there is an existing session, if yes, then fast path. If there is no existing session, then slow path. And these are the 6 tuples compared to the table of the active flows. Just remember. And how we will do how we will check what information be in your session table. This is the command. Show session all. And right now I have, these are the sessions right now I have on my system. This is your ingress stage, guys. Now we have a slow path. Let me just explain the slow path again. In slow path, the very first check is your DOS protection profile and TCP state check, right? And after that, because some information are missing here as well. And after that, what we have here, if you will go, after that we have a user to IP cache, then app ID application based cache, right? This is the thing which they will do. Now they have a app ID, application ID cache, and your user to IP mapping cache. Then your routing lookup. In routing, we have two things: PVF, policy based forwarding, or your fifth table forwarding information. If PVF is there, then this will bypass. If PVF is not there, then they will get the egress interface on the basis of fifth table. Then for the net policies, they do the lookup on the basis of destination net. If there is a destination net, yes, then they will do the secondary lookup into your forwarding table again. If no, then they will enforce here your authentication policies. Then your DOS policies, whatever DOS policy you are having. Then your security policy evaluation will start. And if your security policy is allowing the traffic, if yes, then they will create a session and they will install that particular session into the session table. And guys, this information is wrong. Your DOS policy evaluation happens before the security policy, just remember. And after that, we have a where is that silo path and silo path connection setup. Then we was this is the like in with silo path versus fast path. Escape this particular silo path if there is a session is already there. For packet is an established session, means if there is a session is already established for a packet, then it will always go into the fast path. And this slow path will be bypassed if there is a session is already there on the session table. If no, there's no session, then your packet go into your slow path. Forwarding lookup used to happen, your net policy, your firewall security policies, all these are the things which happens here. Layer 2 to layer 4 firewall processing. Do the net if applicable. Apply the SSL decryption if needed. Now go here. So like it's same thing, layer 2 to layer 4 packet process, firewall packet processing, apply net, apply the SSL decryption needed. If has app or content ID change, if yes, then go for app ID, go for content ID. If we have not configured these things, right? Let's say we have not configured any type of layer 7 profile, then it will go directly towards the forwarding stage. Then we can go here. Let's see in app ID what are the things is happening. Mayur, it's a very good question which you have asked, like why there is there's a net in twice in slow path and fast. It's a very good question, and I was expecting that question from one of you. And let me just explain you that question, and after that I'll go into the app ID. So guys, if you have seen in slow path, as I have mentioned, they do the net evaluation. And fast path, they generally apply the net. Means here they will do the net translation. Now tell me one thing. We have this PC, we have this particular firewall, and we have this server. And we have configured the net here. Net is there. And we have, let's say we have configured the source net. And let's suppose on this server, I'm trying to download a 2 GB of file. So he will send the packet like this. This is the first packet. This is the reply of the first packet, right? Then we have a second packet. Now tell me one thing, Mayur, is the second packet go through your silo path? No. Now I hope you got the answer. Why we are applying the net in first path? Because subsequent request and reply packet we will not send through the slow path. So that is the main reason we have to apply the net on fast path, because without applying the net, your things will not work, right? So that's the concept behind that. Okay, I hope you got it now. It was a very nice question actually. It's a nice catch as well actually. No. In app ID, as I have mentioned, they will check the app override policies. Then they will do the app identification on the basis of pattern based application. Then they will impose the security policies for that application. If there is any type of layers and profile is there on your security policies, they will basically add that particular thing there. Like we have to send this packet for the layers inspection, means we have to send this packet towards the content engine. Set QoS. If there is any decryption is applied, we have to do the re-encryption and other things, but generally this re-encrypt we will do in the content ID. Okay. If there is no content ID, then we will do the re-encryption here as well. And after that, we have this one, which is a forwarding stage. Packet forwarding, BPN, QoS, all these things they will apply and they will forward. Net, they will never apply here. This is wrong. This also they don't check now here at the end. This is the land attack. Source equals to destination. These things they generally check at the starting only. So guys, that's how the packet flow. That's how the PaloAlto firewall going to do the packet processing. Now there is a one topic left from yesterday, which is that is the one initial access. How you will get the initial access basically of your device. Let's try to understand that part. So for this initial access, I will use, there is a one diagram I was having of firewall. Now, guys, tell me one thing. Let's suppose you have received this particular device in your environment. Now your manager came and he just asked, can you just start configuring this particular box? What you will do generally? What is the process followed by the organization? Let's suppose you got a new box. Now you have to do the implementation of that box. What you will do? What is the first activity? You will basically identify the rack and you will identify the rack and server room where you have to put. You will identify all the cabling. You will identify the cabling is there or not. You will also identify the distance between this particular firewall and your core switch and your ISP routers. When everything you will arrange, what? You will do the rack and stack. You will do the rack mounting of this particular box. And after that, once you get the rack mounting, the fourth thing, what? Now you have to get the access of this box. Now how you will get the access of this particular firewall? So for getting the access, guys, in this firewall, if you will able to see, we have this particular port, console port. So we can basically access this firewall with that with the help of this particular port. We can get the console access. And what we used to do, because you know all the management related stuff we used to perform with the help of management port on this particular device. And this device has a dedicated management port, which is this one. So what, once we will get the console access of the firewall, what? Because you know in this console there is a one password is configured. So the default username for PaloAlto is admin and default password for PaloAlto is also admin. And even though in your management interface you have a one default IP address 192.168.1.1. Now after entering these details, what? You will get the console access of this device and you will start doing the management interface configuration. In this management interface, what? You will configure the IP address and net mask. You will configure the default gateway. You will configure the NTP server detail. You will configure the DNS detail and you will configure the host name detail. You will configure the login banner. You will also do the configuration for time zone. These are the basic configuration you need to do with regards to this management interface. And if you will able to configure all of them, what you will do? And you will connect this management port of this particular one of the switch where you have a definitely you have a one management VLAN. Let's suppose in your case you have a management VLAN like 999 or 777. These are the some names or some format used by the organization. So you will put that particular port of switch like let's say F5 on this particular management VLAN, and after that you will access this device from any type of jump host in your production environment or any type of like static environments like or any jump server from where you are accessing the other networking devices. So that's how the process used to happen. with regards to the initial access. We also have some more point on the initial access. Let me just cover that as well. Let me go a little bit down. So generally, for initial access, first time we used to get the console access, and after that we will do the configuration in the management port. We will do the cabling of your management port, and we will able to access the firewall through the management interface, or we can able to access this firewall through the management port. And guys, by default, username to log in into your firewall is admin. When you will log in into the console, password is also admin. Generally, there is a one default IP address is also configured in your management port on the hardware boxes. 192.168.1 in virtual boxes, DHCP client option is there. Means these devices, they will get the IP address from DHCP server if you are running. And guys, your PaloAlto device, it has a dedicated out of band management interface. It's just a normal Ethernet interface, just a normal copper port. It's not a fiber port, just remember. Just a normal 1 gig of copper port. It's a out of band. Sometime you will see OBB, out of band management. These are the terms used by the peoples. And guys, by default in this management port, SHS, HTTPS, and ping, these three services are enabled. Means you can able to do the SHS on the management port of the firewall. You can able to access the firewall with the help of HTTPS, and you can able to get the, you can also able to do the ping. You can able to ping that particular IP address of the firewall. So Maninder, I was talking about the management port. Management port of your PaloAlto firewall. VM is by default has a DHCP client option configured. Means if you have any type of DHCP server here, and so the thing is, as soon as you will connect the cable in the management port of the PaloAlto firewall, it will start sending the discover message. And discover message to DHCP. This DHCP will provide one of the IP address. But the best way, always connect with the console port and configure the static IP address there, because we always configure the static IP on the management port. Now guys, tell me one thing. Generally, why we have a dedicated out of band management? Why we have a dedicated management port? What is the benefit we will get with the if we have a dedicated management port? And what type of traffic we will be expecting on this management port? So guys, the main benefit, we will get this traffic segregation, and we will only send the management related traffic. Like what is the management interface traffic? We have a traffic like we want to take the SHS access of the device. We want to take the HTTPS of a device, because all the configuration related traffic will go through with SHS or HTTPS. Let's suppose if you want to fetch any type of SNMP related information, all your SNMP polling is happening through the management interface. Let's suppose your firewall is needs to do any type of DNS related thing, like let's say it needs to do some name to IP resolution. Your DNS traffic will be sent through the management interface always by default, but you can able to modify. Your NTP related traffic will send through the management interface. All type of signature updates, for your applications, your antivirus signatures, your anti-spyware signatures, your vulnerability signature, all these signatures, my firewall will download from the updates.paloaltonetworks.com with the help of through the management port only. If you are using firewall, if you are managing firewall with the panorama, then your panorama, whatever the communication is happening between firewall and panorama, they will use the management port for that. If you have configured the syslog, your syslog related traffic will go through with the management. If you have configured the user to IP mapping like user ID, then all this user ID related traffic will go through the management interface. So that is the main benefit we will be having, because we are not mixing the users traffic and your management traffic. And these are the, this is the few points which I have written with regards to the management traffic. Let's suppose you have any type of, if you have any type of backup server and you are taking the config backup, that backup server traffic will also happen through the management interface only. Let's suppose you have configured the net flow. The net flow related traffic also you can send through the management port only towards your solar window net flow analyzer. Mubarak, how you can say like update packet is a update traffic is very high? These are the just updates like 10 MB of updates, 20 MB of updates actually. Okay. It's not like updates like we have a 1 gig of updates and all. No, it's not like that. So like net flow traffic, you can able to also send through the management interface. And I've always recommend you can send this traffic through the management interface only. Not needed, you can forward through the data port, not required at all. Okay. And like what if you have configured any type of like email polling and other things, any type of alarm and other thing, that traffic also you can able to send. So let me tell you what type of traffic generally we will forward through the management port. You can go into the service route configuration, customized, like autofocus, CRL status, data services, DNS, panorama, post update, DNS, EDL, email, HTTP, IoT, Kerberos, LDAP, right? They will use by default management port. Your multi-factor authentication, your net flow, Mubarak, so net flow is also, they will forward through the management interface, okay, by default. But you can able to modify your NTP, PaloAlto network services, panorama proxy, radius, SCAP, SNMP trap, syslog, TACAX, user ID agent, URL updates, VM monitor, wildfire, and JetTP. All that traffic they will send through the management interface. Okay, just remember. Now, go here. Let me just see. Okay, guys. So let me just also cover that point as well, because this point is also important. When you have the firewall, generally we can able to control the firewall. We can take the web interface access, or we can take the GUI access of the firewall. By using the HTTPS, we will put HTTPS:// and the IP address of the firewall, and we will get the access via GUI. We can able to also get the access via SHS, via console cable, even though you can also allow to enable the telnet if you want, but telnet is not recommended to allow in the production firewall. You can here, or you can also able to allow HTTP, but not needed. So GUI access we will get from the HTTPS, CLI access we can get from the SHS or console cable. We can also control the firewall. We can do the firewall administration with the help of panorama. And the most important thing, we can control the firewall with the help of REST API or XML API, means with the help of automation. Like we can able to do the automation with the help of Ansible, Python, right? For that, they are using REST APIs or XML APIs. So these are the 4 ways to do the administration or to do the configuration in your Palo Alto firewall. Web interface, Panorama, CLI, and your XML or REST APIs. When you will do when you will log in first time into your firewall, it will basically give you this warning to change your old password, and your old password is a admin one. Just remember, and that password has some complexity, like it is 8 character long, one uppercase, one lowercase, one numeric or special characters. So we will see all these things, how the management interface we can configure, so we can do like that. And remaining thing I will cover later, guys, because this updates and other thing is a part of your next session. Like I will cover your dynamic updates and other things here. So like in your next class, I will try to basically help you with the lab setup. So we will build your lab on VMware workstation, on your EVNG, and also on your Google Cloud platforms. Okay, so from next lecture onward, I will do the lab setup and other things, guys. And today, so I'm stopping here like around 30 minutes before, because we have already completed the topic which I wanted to cover with regards to today's session. And remaining thing we will discuss in your next class.